All right. This unit is going to, it's called comparing functions, and it's going to look at the three different types of functions that we've covered this year. We started the year with linear, then most recently we did exponents, exponential functions, and then we also did quadratics in between there. So we had a unit on this way earlier in the year, but this is called function notation. And so this is just going to be a quick review of function notation and kind of how it works and how things are written and how to use it. And then we'll get into some of the more specifics on comparing the actual different types. So this says evaluate the following expressions given the functions below: g of x, f of x, h of x, and j of x. If you remember from the function notation unit, if I have g of 10, that really means, well, let me make that smaller, hold on. That really means that x equals 10. And so all I do is plug in a 10 right here for x and evaluate or find what it equals. So that would be negative 3 times 10 plus 1. That's negative 30 plus 1 is negative 29. Okay. B, f of 3, that means you are plugging in a 3 for x. So 3 squared is 9 plus 7 is 16. H of negative 2, that means I'm taking x and plugging in a negative 2, so that's 12 divided by negative 2 is negative 6. J of 7, 2 times 7 is 14, plus 9 is 23. H of A, this basically just means that you're plugging in A instead of X. So this is just 12 over A. Obviously, you can't go any further than that. You don't know what A is. So H of A is really just 12 over A. G of B plus C, it looks a lot more complicated than it really is. Remember, this whole thing here is just x. So you take the function g, and in place of x, you put b plus c, and that's it. Now find x if g of x equals 16. This is the key here. G of x equals 16. So instead of g of x, I write 16 equals negative 3x plus 1. Now you just go through the steps to solve an equation. And you get x equals negative 5. Find x if h of x equals negative 2. So negative 2 equals 12 divided by x. This is a little bit tricky to solve. You can either look at it as like, what do I need to divide 12 by to get negative 2? Or to get x out of the denominator, you can multiply both sides by x. This is kind of the algebra way of doing it. Those cancel out. Then divide by negative 2, and you get x equals negative 6. F of x equals 23, so 23 equals x squared plus 7. And you get x equals plus or minus 4. Okay? So that's just a quick kind of review of how function notation works. Here we are given a function and we need to fill in the table. So we're basically just plugging in different x values and finding what this equals. So like for instance, this -6 would be f of x equals 3 minus 4 times -6. Well, that's 3 plus 24, which is 27. If I put in a -3, that's -4 times -3 is 12, plus 3 is 15. If I put in a 0, that's just 3. And if I put in a 1 right here, that's -4 times 1 is -1, plus 3 is 2. If I want to find this, I do -5 equals 3 minus 4x. Solve for x. You get x equals 2. Then when we go to sketch a graph of this, if I rewrite this in a more familiar form, this is actually really easy to graph. Okay, so it has a y-intercept of 3 and a slope of -4, so down 4 over 1. And there's sort of how that line looks. Over here, plug in the different values for x. So this would be square root of 3 plus 1, which would be square root of 4, which is 2. Square root of 0 plus 1, that's square root of 1, which is 1. Square root of -9, that doesn't exist. If I put in a 2, I get square root of 3. And if I solve this for 6, I get 6 equals, square both sides to get rid of the square root. And this is either positive or negative. Let's see, this could be, x could be, we'll just go with the positive one, x is 35. We actually are not going to talk about how to graph this. In fact, the table, like for plugging in and solving purposes, is fine. I'm not too worried about this. So if you totally lost there, don't really worry about it. Not a big deal. That looks more like an angry face or a pouty face than a sad face, but you know, whatever. But don't worry about that one too much. Translate the following statements into coordinate points, then plot them. The key here is remembering that typically it's f of x equals whatever. So this has been replaced by a number, meaning that the x-coordinate is -1, and what usually goes in the y-coordinate is 1. In general, these are going to be x comma f of x is how these coordinate pairs work. You are kind of used to this, but these two things are the same. So this is really like a -1 comma 1. This is really like a 2 comma 7, 1 -1, and 3 0. So then just plotting the points, there's a 2, 1, 2, 3, 4, 5, 6, 7. There's B. 1 -1, there's C. And 3 0 part D. Given the graph of the function f of x, find f of -4. This, again, if there's a negative 4 there, that means x equals negative 4. So we go on the x-axis, we look for negative 4, which is right here. We follow it up to the line, and that's right at 2. F of 0 is right here at 0. F of 3, that's where x equals 1, 2, 3. Looks like it's almost negative 2, maybe like negative 1.8. F of negative 5, that's where x is negative 5, that's 0. X when f of x equals 2. Now, what we're looking for is when f of x equals 2. So I'm looking on the y-axis at any point that this line crosses 2. So it looks like x equals negative 4 and x equals almost negative 1, maybe like negative 0.9. X when f of x equals 0, that would be here and here. So that's x equals negative 5 and x equals 0. Okay? This one, we have h of 1 equals 6, h of 4 equals negative 3, and it says find an equation. This sounds really difficult, but the little hint here, it's the same as writing the equation given 2 points. The 2 points we are given are 1, 6 and 4, negative 3. So first we can find the slope between them. If you want to put them into a table, you can do that. If you want to use the slope formula, y2 minus y1 over x2 minus x1, you can do that too. But basically, either way, we're going to be looking for the change in y over change in x. So it looks like our change in y is from 6 to negative 3, that's a change of negative 9, over the change in x from 1 to 4, that's a change of positive 3. If I simplify that, I get negative 3. So the slope of this is negative 3. So far in my equation, I know y equals negative 3x plus something. To solve for the something, I take one of these points and I plug it in. So I'm going to take 1, 6. That's going to be a 1. That's going to be a 6. And I get 6 equals negative 3 plus b. Add 3 to both sides. And b equals 9. So the last part of my equation is 9. So it's negative 3x plus 9. If I write it in function notation, it's just f of x. Oh, sorry, h. H of x equals negative 3x plus 9. Okay? Last one, swine flu is attacking Porkopolis, that one. The function below determines how many people have swine where t equals time and s is number of people. So if we are finding s of 4 in this equation, we are taking 4 and plugging it in for t. So that would be 9 times 4 minus 4. That's 36 minus 4 is 32. What does s of 4 mean? Remember, we plugged in 4 for t. That t was days. So that means the s, number of people, with swine after 4 days. find t when s of t equals 23. So I'm taking s of t, setting it equal to 23. So I get 23 equals 9t minus 4. Now I'm solving an equation, add 4 to both sides, divide by 9, you'll get 27 divided by 9 is 3, t equals 3. Then this s of t equals 23, what does that mean? It means what we're finding is t, right? So we're finding t time in days. So how many days before 23 people have swine flu? Graph the function. This is actually pretty easy. You know this is kind of the t-axis and this is the s of t. So you know the slope is 9. You know the y-intercept or the whatever intercept is -4. 1, 2, 3, 4. You go up 9 over 1. That's the slope. And here's what that line looks like. Okay? So that's just a quick not intro, but kind of reflection on what function notation looks like and how we have used it.